When sizing service entrance cable for two-family and multi-family dwellings, consider these general rules of thumb. For 100 amp panels, a 100 to 150 amp service entrance cable may be suitable. For 150 amp panels, a 150 to 200 amp service entrance cable is a good range. For 200 amp panels, consider a 200 to 250 amp service entrance cable. In a scenario with two 100 amp breaker panels, a 150 amp service entrance cable might suffice based on the rule of thumb. However, upgrading to a 200 amp service entrance cable provides extra capacity for future needs. Remember that this is a general guide, and accurate sizing requires a comprehensive approach. Firstly, perform detailed load calculations for the entire building to accurately determine the electrical demand. This calculation should account for all anticipated loads, including lighting, appliances, heating, and cooling systems. Secondly, adhere to local code requirements. Consult the local building code for specific regulations regarding service entrance cable sizing, as these codes can vary significantly. Thirdly, check utility guidelines. Some utility companies have specific requirements for minimum service entrance cable sizes in multi-family dwellings. It is recommended to conduct a load calculation and consult with your local building department and utility company to determine the right service entrance cable size. Choosing a larger capacity service entrance cable provides a safety margin for potential future expansion. Let's elaborate on load calculations. Load calculations involve a systematic assessment of the anticipated electrical demand of a building. The National Electrical Code, specifically Article 220, provides detailed guidelines for conducting these calculations. There are two primary methods: firstly, the standard method, and secondly, the optional method. The standard method is more conservative and is typically used for larger or more complex installations. It involves calculating the general lighting load, receptacle loads, appliance loads, and motor loads, among others. The optional method is simpler and can be used for dwelling units, but it may not be as accurate for all situations. When performing a load calculation, start by determining the general lighting load. According to the National Electrical Code, the general lighting load for dwelling units is typically calculated at 3 volt amps per square foot. Multiply the square footage of the building by 3 volt amps to determine the total general lighting load. Next, calculate the receptacle loads. Receptacle loads are typically calculated at 180 volt amps per outlet. Count the number of receptacles in the building and multiply by 180 volt amps to determine the total receptacle load. Then, determine the appliance loads. Appliance loads can vary depending on the type and size of the appliances. For small appliances, such as toasters and coffee makers, use the nameplate rating of the appliance. For larger appliances, such as refrigerators and washing machines, use the value specified in the National Electrical Code. Next, calculate the motor loads. Motor loads are typically associated with equipment such as air conditioners, heat pumps, and well pumps. Use the nameplate rating of the motor to determine the motor load. Once you have calculated all the individual loads, you can apply demand factors to account for the fact that not all loads will be operating simultaneously. Demand factors are specified in the National Electrical Code and vary depending on the type of load and the number of loads. After applying the demand factors, sum all the loads to determine the total calculated load. This value is used to size the service entrance cable and other electrical equipment. It's important to consider future expansion when sizing the service entrance cable. If there is a possibility that the electrical demand of the building will increase in the future, it is best to install a larger service entrance cable to accommodate the additional load. This can save time and money in the long run, as it will avoid the need to replace the service entrance cable later. Now let's look into local code requirements. Local building codes are established by municipalities and other local government entities. These codes are based on national standards such as the National Electrical Code, but they may also include additional requirements that are specific to the local area. It is essential to consult the local building code before beginning any electrical work, as failure to comply with the code can result in fines, delays, and other penalties. Local codes often address issues such as the minimum size of service entrance cables, the type of wiring methods that are allowed, and the requirements for grounding and bonding. They may also include specific requirements for multi-family dwellings, such as the need for individual metering of each unit. To find the local building code, contact the local building department or visit the municipality's website. The building department can provide information on the specific requirements for electrical installations in the area. In addition to the local building code, it is also important to check with the utility company to determine if they have any specific requirements for service entrance cables. Some utility companies have minimum size requirements for service entrance cables, and they may also require that the service entrance cable be installed in a specific location or manner. The utility company can provide information on these requirements and can also assist with the process of connecting the service entrance cable to the utility grid. When selecting a service entrance cable, it is important to consider the ampacity of the cable. Ampacity is the maximum amount of current that a conductor can carry safely without exceeding its temperature rating. The ampacity of a service entrance cable is determined by its size, material, and insulation type. The National Electrical Code provides tables that list the ampacity of different types of conductors. These tables can be used to select the appropriate size of service entrance cable for a particular application. It is also important to consider the voltage drop in the service entrance cable. Voltage drop is the decrease in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause equipment to operate inefficiently or even fail. The National Electrical Code provides guidelines for calculating voltage drop and for selecting conductors that minimize voltage drop. To minimize voltage drop, it is best to use a larger size of service entrance cable or to run the cable a shorter distance. Additionally, consider the environmental conditions in which the service entrance cable will be installed. If the cable will be exposed to sunlight, moisture, or corrosive substances, it is important to select a cable that is rated for these conditions. Service entrance cables are available with a variety of insulation types, each of which is designed for specific environmental conditions. For example, some service entrance cables are rated for direct burial, while others are not. Other factors to consider include the type of termination connectors that will be used and the ease of installation. Select termination connectors that are compatible with the service entrance cable and that are easy to install and maintain. Also, consider the flexibility of the cable, as this can make it easier to route and install in tight spaces. In summary, sizing the service entrance cable for a two-family or multi-family dwelling requires a comprehensive approach that considers load calculations, local code requirements, utility guidelines, and environmental conditions. It is important to consult with qualified electrical professionals to ensure that the service entrance cable is properly sized and installed. They can help perform accurate load calculations, interpret local code requirements, and select the appropriate service entrance cable for the specific application. Always remember safety is paramount when working with electrical systems. Work should be performed by qualified personnel and adhere to all relevant safety regulations. Now let's delve deeper into the types of service entrance cables commonly used. There are several types of service entrance cables, each with its own characteristics and applications. Some of the most common types include, firstly, service entrance cable with type XHHW insulation, secondly, service entrance cable with type RHW insulation, and thirdly, aluminum service entrance cable. Service entrance cable with type XHHW insulation is a cross-linked polyethylene insulated wire that is commonly used for service entrance applications. It has a high temperature rating and is resistant to moisture and chemicals. Service entrance cable with type RHW insulation is a rubber insulated wire that is also commonly used for service entrance applications. It is less expensive than type XHHW insulated wire, but it has a lower temperature rating and is not as resistant to moisture and chemicals. Aluminum service entrance cable is a lightweight and cost-effective alternative to copper service entrance cable. It has a higher resistance than copper, so it is important to use a larger size of aluminum wire to achieve the same ampacity. In addition to the type of insulation, service entrance cables are also available in a variety of sizes. The size of the service entrance cable is determined by its ampacity, which is the maximum amount of current that the cable can carry safely. The National Electrical Code provides tables that list the ampacity of different sizes of service entrance cables. These tables can be used to select the appropriate size of service entrance cable for a particular application. Let's consider grounding and bonding. Grounding and bonding are essential safety measures that protect people and equipment from electrical shock. Grounding is the process of connecting electrical equipment to the earth, which provides a low impedance path for fault current to flow back to the source. Bonding is the process of connecting all metal parts of an electrical system together, which ensures that they are at the same potential. The National Electrical Code requires that all electrical systems be properly grounded and bonded. The grounding electrode system typically consists of a grounding electrode conductor, a grounding electrode, and a bonding jumper. The grounding electrode conductor connects the electrical system to the grounding electrode. The grounding electrode is a metal rod, pipe, or plate that is buried in the earth. The bonding jumper connects all metal parts of the electrical system together. When selecting grounding and bonding equipment, it is important to choose equipment that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories. This ensures that the equipment meets the applicable safety standards. Additionally, inspect the grounding and bonding connections regularly to ensure that they are tight and free of corrosion. Corrosion can increase the resistance of the connections, which can reduce their effectiveness. Remember that working with electricity is inherently dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock. Always to energize the circuit before working on it, and use appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. In addition to the technical aspects of sizing service entrance cables, it is also important to consider the aesthetic aspects. Service entrance cables can be unsightly, so it is important to choose a cable that is aesthetically pleasing. Service entrance cables are available in a variety of colors and styles, so you can choose a cable that blends in with the surroundings. Additionally, you can conceal the service entrance cable by running it through conduit or by burying it underground. When concealing a service entrance cable, it is important to follow the manufacturer's instructions and the National Electrical Code requirements. This will ensure that the cable is properly protected and that it meets all applicable safety standards.